Alright, you are welcome to our class this evening. I want to sincerely apologize for not doing more videos over time. But this evening we are going to be looking at some trigonometric identities. There are three basic identities that we want to prove this evening. But for we to do that, we need a circle. As the diagram above is a unit circle with radius 1 unit long. So triangle PON, inside the triangle we have a triangle PON. I have PON is a right angle triangle with PN equals to Y, OP equals to 1, and then ON equals to X, and then the angle PON is equal to theta. So by definition of trigonometric ratios, we have that what cos theta is equals to what x, that's equation 1. Sin theta is equal to what y, that's equation 2. Now when we square both equation 1 and equation 2, you square the left hand side, you also square the right hand side. So squaring equations 1 and 2 will gives cos squared theta is equals to x squared, and then sin squared theta is equals to y squared. So question this is equation 3, and then this is equation 4. Okay, so now we have equation 3 and 4. But we got equation 3 and 4 by squaring equation 1 and equation 2. So now that we have squared it, now is to add both equation 1 and equation 2. So when you are adding two equations together, you add the left hand side together and also add the right hand side together. So when we say adding equation 1 and equation 2, we add it in this format. So we say, we come here, equation 1 is what? So we have what? Cos squared theta plus sin squared theta is equals to x squared plus y squared. That will give us equation 5. So we have added equation 1 and equation 2. Now note, now we bring out this triangle. We know that what? By Pythagoras theorem, we have that what? X squared plus y squared is equal to what? 1. So let's call the equation 6. So by Pythagoras theorem, since this triangle here is a right angle triangle, it will obey Pythagoras theorem. X squared plus y squared is equal to 1 according to Pythagoras rule. So now we have seen it, now we can compare both equation 5 and equation 6. Now look at the left hand side of equation 5. We have that what? X squared plus y squared is equal to what? We have equation cos squared theta plus sin squared theta is equal to x squared plus y squared. So if you look at it now, since the left hand side, the right hand side of equation 5 is equal to the left hand side of equation 1, so we can equate both. You can equate both of them. So that means that since this one is 1, we can replace it there. So comparing 5 and 6, we have that what? Cos squared theta plus sin squared theta is equal to 1. That is the first identity. That's equation 7. Now that we have gotten equation 7, how do we get the other identities? So we divide equation 7. Divide 7 by cos squared theta. So now we divide the left hand side and the right hand side. So we divide here. So we have what? Cos squared theta over cos squared theta plus sin squared theta over cos squared theta is equal to 1 over cos squared theta. And we know that these two people, they are the same. When the given number is dividing itself, what we always have is what? 1 plus, remember that sin theta over cos theta is equal to what? Tan theta. So we can replace this by tan theta. So we now have what? Tan squared theta is equals to, what is 1 over cos? 1 over cos is sec. So we now have what? Sec squared theta. That's the second identity, that's equation 8. So we call equation 8 the second identity. So let's look at the third identity that we are trying to look for. So again, we still go back to equation 7. We divide equation 7 by what? Sine squared theta. Remember the first one we divided with cos squared theta. Now we are going to divide by sine squared theta. So dividing the equation 7, divide 7 by sine squared theta. So this implies that we have what? Cos squared theta divided by sine squared theta plus sine squared theta divided by sine squared theta is equals to 1 over sine squared theta. So when we divide, this will now become what? Cos over sine is what? Cot squared theta plus 1 is equals to cosec squared theta. Now this is equation 9. So equation 8, 7 and 9 are the three trigonometrical identities that we can relate to. So these identities are very important. We are going to be using them in our subsequent videos on how to prove other identities. Thank you very much and have a good night rest.